Okay, we are going to look at how we can use the cross product to find area in this video. In the last one, I was kind of like, well, what does this 17 mean, right? So here I've got a different pair of vectors. Let's quickly find A cross B. That's equal to det. Right, I got, here, actually, well, yeah, I'll do it. I hat, J hat, K hat. And then what do I have? I have 5, 0, 0, and then 0, 3, 0, like that. So now I'm going to show you like the quicker way that I use instead of using an actual I hat, J hat, K hat in the next line. What I do is I draw my open bracket and then I go like that with a det. And then I put a negative and I put another det and then I put another det and then I close my bracket. And then I fill in the numbers accordingly. This one gets the one where the I hat's covered up. So it's 0, 0, 0, 3. The next one gets a 5. It's the J hat covered up. 0. And then 0, 0. And then the last one gets 5, 0, 0, 3. Now I chose these two vectors because this, you'll see. All right, so that is, the first one, this product here is 0 minus 0. So it's 0. This one is negative, but it's 5 times 0 minus 0. So it's again 0. And then this guy here is 5 times 3 minus 0, which is 15. So I sort of already alluded to this, but I said cross product to find area. So I want you to think about what area would be, like this. How are the numbers that I have there related to area? Well, let me show you. If I were to, this is a 3D representation. If I were to look straight down the z-axis and not see this thing, and have the y-axis like this, and the x-axis like this, we'll go 1, 2, 3, 4, 5. 1, 2, 3. Draw my vectors. This would be B. This would be A. Do you see that they actually, if I were to copy B over here, and then copy A over here, I get a rectangle. Well, what's the area of that rectangle? The area is base times height. Well, that's 5 times 3. Notice that's 15. Now, you may say, all right, well, that's the z component here. But what's really important here is that the length, let me do it back in blue, the length of this vector, the length of A cross B, which is the length of 0, 0, 15, is 15. And that matches this right here. And that's actually always going to be true. Every pair of non-parallel vectors forms a parallelogram. So I'll hit pause and write that. Every pair of non-parallel vectors forms a parallelogram. You may say, hey, that's a rectangle, but what if B went like this and A went like this? Then I could draw a parallelogram like that. Do you see that? I'll do it down here. So, if this is B and this is A, then what I can do is, like I said, copy B like this, copy A like that, and I'm trying, and then get this parallelogram right here. So this is a copy of B. This isn't the best picture, but hopefully you see what I'm trying to do. And this is a copy of A. Much better picture here. I use the fact that I have a grid here. So this would be a copy of A, and this would be a copy of B. The area of this parallelogram is always going to be the length of A crossed with B. So in this example up here, it was really easy to calculate the length because it only had one component. So if you had one where it had multiple components, you'd have to use Pythagorean theorem. So we are going to do a couple examples. And, oh no, I want to talk about one more property. All right, so let's look at this thing up here. A cross B. I got, let me just copy this. Oops. I just copied this so that you can see it, but A cross B. Now I'm going to look at what B crossed with A is, and it's not necessarily what you would think it is. For example, if I had 10 times 3 and I multiply them, some scalars, I get 30. If I do 3 times 10 the other way, I also get 30. A times B is the same as B times A. So the intuition with cross product would be say, hey, A cross B is whatever. It should be the same as B cross A. But watch what happens here. I hat, J hat, K hat, and then I'll flip them. So I go 0, 3, 0, and then 5, 0, 0. And when I do my vectors, boom, boom, comma, negative, boom, boom, comma, boom, boom. Let's put our pieces in. 3, 0, 0, 0. This guy gets 0, 0, 5, 0. And this guy gets 0, 3, 5, 0. What I want you to see is that this is equal to 0 on the first component, 0 on the second component, and then I do this, but this product of 3 times 5 is the back part of the determinant, so it's negative 15. So notice this is negative of this thing, so it's negative A cross B. That is actually something that's always going to be true. A cross B is negative B cross A. Or you could flip the negative on the other side. But that's always going to be true. All right, so now I have one example where you're going to answer a bunch of questions for me, and I will do that in one moment. Here's a 4-part problem for you to do. I give you a vector A and a vector B, 3, negative 1, 2, and 1, 5, negative 1. And I want you to give me these 4 things. The 2 cross products, I want you to calculate them using the determinants, using the cross product, not the not this property. So you're showing me that this property is true for these 2. And then I want you to show me that A dotted with A cross B is 0. That should be true because A cross B should be perpendicular to A. And then I want you to find the area of the parallelogram formed by A and B. So you can hit pause and do this, and then I will pop the answers up and go through them, and then we'll be done. Here come the answers. Here are all your solutions. So I started with A and B. I did A cross B. I did it with just the bracket instead of I hat, J hat, K hat thing here. Negative 9, 5, 16. B cross A came to be 9, negative 5, 16. That was good. It's the opposite of this one. It should be that. And then this right here is when I dot it out, when I multiply these, I get negative 27 minus 5 plus 32 equals 0. That's good. And then the area of that parallelogram is just the length of this one. So I Pythag the whole thing, and I get this. Now, I'd like to talk for one moment about this and this, because it goes all the way back to the very beginning, right? Or the fact that B cross A is the negative of A cross B. Well, come up here, all the way up here. Remember, I had a purple marker that went up, and I had a purple marker that went down. So the one cross product, if I do this one with that one, is going to actually give me this right here. If I cross them the other way, if I do this one with that one, then it goes down. I'm going to try to explain this, and it's going to be really hard. But if you take your hand on this picture here and kind of place it right here and then stick your fingers out this way. Oh, sorry. I should say what hand? Your right hand. Okay? So actually take I got a hand right here. Take take the very beginning of your pinky finger, where your pinky meets your hand, and put it at the intersection here. Now, curl your hand from this guy to that guy. If you can, then what that would be represent, this is called the right hand rule, and I'll try to explain in class too. But if I stick my hand out with the one with the white part and curl it towards the one that doesn't have that white piece, then my thumb sticks up. Well, the right hand rule tells us if that curl works, that the direction that your thumb goes will be the direction of the cross product. Here, you would have to, if I was doing this guy crossed with that guy, I would have to turn my hand upside down in order to curl my right hand from here to there, and my thumb would point down, and that's the right hand rule. And I'll try to explain that again when you guys can actually see my hands moving. But hopefully you are cool with determinants, you are cool with this perpendicular idea, with cosines and dot products, and you can do all this stuff right here. That's all I got. Bye.